Oil and gas fuel our modern life, from our infrastructure to industry and our home. The world can't live without oil and gas, and yet it's getting harder and harder to acquire every day. My name is Khoo Jun Kai, and I'm a pipeline engineer from OnePetro Solution. OnePetro Solution is a company that provides engineered solutions to your subsea infrastructure. We combine our innovative technologies to remediate blockage from subsea flow line, enable it to restore the production faster. We are really honored to work on this oil field. This oil field is called Bach Ho oil field. It's located in Vietnam. Pipelines in these oil fields are lacking of thermal insulation. The temperature of the water at the seabed is ranging from 25 degrees Celsius to 28 degrees Celsius. At some point where it's the lowest temperature, it will reach to 21.6 degrees Celsius. Sample crudes from Bach Ho oil field shows around 29% of paraffin content. This is considered high, and this high paraffin content will cause wax deposition on the pipeline. Wax deposition can lead to several technical issues, such as a reduction of diameter in the pipeline, reducing the operating capacity of the production system, or in extreme cases, blockage of the whole pipeline. All these technical issues can lead to financial loss to a company. The pipeline that we are looking at is actually 380 kilometers. For the study, we are going to take a section of 100 meters from the pipeline. This specific section is actually selected from the manual calculation. We are going to do the pipeline simulation using ANSYS software, and 4 conditions will be studied that are bare steel flow line without thermal insulation, steel flow line with thermal insulations such as epoxy and concrete, pipe in pipe with hydrocarbon and hot water, and pipe in pipe with hydrocarbon and hot air. Our objective is to first identify the temperature distribution along the pipeline, and then to propose the best solution for heat loss along the pipeline to prevent the wax deposition.
Hello everyone, my name is Chaq and I'm a pipeline engineer from OnePetro Solution. We have approached several ways to approach the paraffin problem. So the first one is just a bare pipe as our benchmark, and the second one is insulated with buried in soil. Then the next one is pipe in pipe with hot air transfer in it, and pipe in pipe with hot water traveling through it. So these 4 cases is the way to approach our solution, which will give a different kind of perspective for our organization to see how to tackle the problem. From our case study of the paper, the paraffin is deposited below a 57 degrees Celsius and have a evaporation point at 57 degrees Celsius with a saturation. To ensure that our simulation result is as accurate as possible, our meshing play a crucial part in our result. So for the meshing, our skewness is 0.5, which is below 0.9, while our aspect ratio is between 0.9 to 2.5. While for the setup, single phase flow is being chosen because we are only dealing with a gas flow along the pipeline. And then K epsilon is absolutely a must, as there will be a turbulence inside the pipeline, while energy transfer is also selected on, as there will be a heat transfer between the pipeline to the surrounding or the pipe in pipe. So from our 4 case study mentioned earlier, the bare pipe, which is the benchmark of our simulation, give a significant temperature drop, which is around 66 Celsius for a 50 meter pipe. This is unacceptable at all because our pipeline is 300 km long, and for a 6 degree, that drop in a 50 meter is unacceptable. While for the buried and insulated pipe, The temperature drop is very noticed, which was about 0.002 degrees Celsius along the 15-meter pipeline. As for pipe with hot air, the temperature managed to increase with the hot air inlet of 50 degrees Celsius, where the result of the gas travel at outlet with a slightly drop about 0.02 Celsius, which is surprisingly worse than an insulated and buried pipe, and is more expensive in terms of operational costs. Lastly, for the pipe with hot water at 90 degrees Celsius with a speed double the amount of gas travel, 142.5 meter per second, the result at the air gas outlet temperature increased by approximately 5.5 degrees Celsius, which is more than required as the saturation temperature for our case is 57 degrees Celsius. In comparison with all the cases being simulated, the pipe with hot water gives us the best choice for our solution. This is because for buried and insulated pipe, the temperature drop is around 0.002 degrees Celsius, which is unacceptable for a 380 km pipeline. This also explains for the pipe with hot air, which give a higher temperature drop compared to buried and insulated pipe. Moreover, the pipe with hot air will cost more for operational, whereby the boiler maintenance, the pipeline maintenance, and the pump maintenance. So back to the insulated and buried pipe, the temperature drop is small. But for a 300 km pipeline, this is unacceptable as the paraffin will still manage to deposit. So to summarize, the best solution for our paraffin problem is still the pipe with hot water. In conclusion, for the past 12 weeks of study and simulation, the best solution for OnePetro solution to approach this paraffin problem in Bac Ho Field, Vietnam is pipe with hot water. Despite pipe with hot water being the best solution, a further study needs to be done as the temperature and the flow rate of the hot water still need to be managed to optimize the temperature at 60 degrees Celsius to minimize the operational cost. 60 degrees Celsius need to be maintained without increasing or decreasing to decrease our maintenance and operational costs to the lowest. With that, we end our presentation today. That's all from OnePetro Solution. Thank you.